Hello class, in this video I will be discussing about dynamics of circular motion during uniform circular motion. Okay, if you remember this formula, the acceleration or the perpendicular acceleration, which is equivalent to v squared over r, or 4 pi squared r over t squared. So if we are going to relate this in net force, okay, that would be equivalent to the mass and the perpendicular acceleration, or mv squared over r. So in example number 18, a sled with a mass of 25 kg rests on a horizontal sheet of essentially frictionless ice. It is attached by a 5-meter rope to a post set in the ice. Okay. Once given a push, the sled revolves uniform in a circular round around the post. If the sled makes complete revolutions every minute, find the force F exerted on it by the rope. So the given here would be, of course, the mass which is equivalent to 25.0 kilogram, the radius which is equivalent to the 5 meter, because that is a 5-meter rope. Okay, and then the t, or the period, which is equivalent for 60 seconds, equivalent to minute, over the 5 revolution. Okay, so if we are going to draw the free body diagram, for example, this is the sled. Okay, and the force acting on it are, of course, the tension of the rope, okay, the tension of the rope, okay, and of course the weight of the sled. All right. Okay, so uh getting the horizontal, okay, forces, that would be equivalent to just the F equals to uh m, and the mass and the perpendicular acceleration, right? Okay, so if we are going to get the vertical, that will be equivalent only to the weight, which is going down, and of course equivalent to 0, because the movement is only horizontal. Okay, so let's focus on this formula. F is equals to m a rad. Based on the given, okay, the formula for a rad, or the perpendicular acceleration, should be based on the period. Okay, so that it would be 4 pi squared r, okay, over t squared. Alright, okay, so if we are going to substitute, that would be m times 4 pi squared r over t squared. So F is equals to 25.0 times 4 pi squared times the r, which is 5.00, okay, divided by the period, which is equivalent to 60 over 5 revolution. Okay, so F will be equivalent to, let's get the calculator. Okay, so that will be equivalent to 25 times 4 times pi squared times 5 over 60 over 5 squared. Okay, sorry. This is squared. Yan. Okay. So that would be equivalent to 34.26. So inspecting the significant figure, the fewest significant figure would be 3. So this would be equivalent to 34.3 Newton. So that would be the final answer. Okay. Let's get just a calculator. Okay, so let's proceed to the next example. Okay, example number 19. An inventor designs a pendulum clock using a bob with mass M at the end of a thin wire of length L. Instead of swinging back and forth, the bob is to move in a horizontal circle at a constant speed V, with the wire making a fixed angle beta with a vertical direction. This is called a conical pendulum. Because the suspending wire traces out the cone, find the tension F in the wire and the period T, or the time for one revolution of the bob. Okay. So first, of course, let's do the free body diagram. So for example, this is the particle or the bob. Okay. The force acting on it would be, of course, um, the tension of the wire. Okay. The tension of the wire. Yan. Okay. So if the tension of the wire will have a uh, vertical component and horizontal component. Okay. And of course, there is the weight. Okay. So if you're going to get the summation of forces, uh, let's do the horizontal forces first. Okay. So we have the horizontal component of the tension, which is equivalent to F. Or if this is F, this would be F sine beta. Okay, this is the angle. So sine, okay, horizontal equals, okay, so because the acceleration is or the movement will be horizontal, so this would the movement would be M a rad. Okay, that is a rad. So if we are going to do the vertical, okay, so the vertical component would be Fy, so that is cosine, and then the weight, okay, the weight, which is equivalent to minus mg, which is the weight, equals 0. Okay, so manipulating the equation, this would be F equals to M a rad over sine B. Okay, so since the x component will be going to the left, so this would be negative, and the acceleration, the pull of acceleration towards the center would be negative also. So negative, negative, that would also be positive. Okay, so next, the y component, if we manipulate this, F is equivalent to mg over cosine beta. So equating the two equations, okay, this is equation 1 and equation 2. Equating the two equations, that would be m a rad sine beta equals mg cosine beta. So the mass will be cancelled. If you're going to get the a rad, that would be equivalent to sine beta cos beta, or tan beta times g. Okay, so um, of course we know that the formula for the uh, perpendicular acceleration would be 4 pi squared r over t squared. Okay, so let's equate the two equations. That would be g tangent beta equals 4 pi squared r over t squared. So let's find first the period. Okay, the period will be equivalent to, let's manipulate this. This would be t equals square root of 4 pi squared r over g tangent beta, or t is equals to 2 pi square root of r g tangent beta. Okay, let's continue this in this side. Okay, so t is equivalent to square root of 4 pi squared r g tangent beta. Okay, and we know that 4 pi squared, let's uh, square it, so that would be 2 pi r g tangent beta, and r, okay, because the given is L, in terms of L, r is equivalent to 2 pi. L is this, okay, so this is the r, so that would be L sine beta over g tangent beta. Okay, so manipulating this equation again. Okay, 2 pi, we all know that g tangent would be sine beta over cosine beta. Okay, this will be cancelled. Cosine beta will be in the numerator part, so t is equals to 2 pi square root of L cosine beta over g. So this is the equation for the period. Now, in order for us to get the f of the wire, okay, so let's just okay, so we know that f is equals to m a rad. Okay, and f is equals to m a rad is equivalent to g tan b, or g a rad, ayan o, g tan b. Okay, so m is equals to g tangent beta. Okay, so if it, in terms of uh, we can use this one, okay, or in terms of the period, okay, let's use this one. um okay, so we can use this one. Okay, so let's proceed to the next example. For a car traveling at a certain speed, okay, the next example is here. Okay, example 20, the sports car in example 7 of module 2 lesson 3 is rounding a flat unbanked curve with radius r. If the coefficient of static friction between tires and road is this mu s, what is the maximum speed V max at which the driver can take the curve without sliding? Okay, so if you remember the problem, example 7, module 2, lesson 3, this is the problem. Okay, so first, let's do the free body diagram. Okay, of course, of course, we have the force, or the centripetal force going there. Okay, and then um, the friction. Okay, okay. There will be a frictional force, because the centripetal force, or is towards the center. There will be a frictional force which will uh, prevent the car from sliding. Okay, this is the F. Okay, and then there will be a normal force, and of course the weight. Yeah. Okay, so if we are going to uh, do the summation of forces, okay, F, or the frictional force, which is going to the left, is equivalent to, of course, the movement would be horizontal, so m a rad. Okay, and summation of forces, Fy. Okay, so that would be equivalent to the normal force minus the weight, is equals to 0. Okay, so we know that the frictional force is equivalent to mu m, right? Okay, so, and n is equivalent to weight, or the mg, so frictional force is equivalent to mu mg. Okay, so if we are going to equate this equation and this one, that would be mu mg is equals to m a rad. Okay, so mu g is equals to a rad. And mu g is equals to a rad would be v squared over r. Okay, so the maximum velocity is equivalent to the square root of, this is, yeah, mu, I am sorry, mu g r. So this would be the final answer. Okay, okay. So next, let's proceed to the next example. For a car traveling at a certain speed, it is possible to bank a curve at just the right angle so that no friction is needed to maintain the car's turning radius. Then a car can safely round the curve even on wet ice. Your engineering firm plans to rebuild the curve in example 20 so that a car moving at a chosen speed v can safely make the turn even with no friction. At what angle beta should the curve be banked? Okay, so para uh, para hindi mag-slide without friction, hindi na kailangan ng friction, you have to bank the curve. So, ano daw yung angle, or the banking angle, para no need friction at makaka-turn yung kotse. So, of course, we need to do the free body diagram. If this is the car, this is the normal force, because ito yung surface, so this is the normal force. And then the acceleration is of course towards the center. Okay, so the x components would be um, n, okay, uh, horizontal, so this is the n, so n would be sine, okay, n sine beta, okay, is equals to, of course, the horizontal would be uh, the movement, so dyan yung perpendicular acceleration natin, okay, and the vertical would be n cosine beta equals to, ay minus the weight, nakalimutan ko yung weight, okay, minus mg is equals to 0, so n cosine beta is equals to mg. Alright, okay, so let's manipulate this equation. So n is equals to m a rad over sine beta for equation 1, n is equals to mg cosine beta, this is equation 2, so m a rad sine beta equals to mg cosine beta, so the mass, okay, so the a rad is equivalent to sine beta over cosine beta, so g tan beta, okay. Okay, we know that a rad would be v squared over r equals to g tangent beta. So getting the angle, that would be tan beta is equivalent to v squared over rg. Okay, so beta will be equivalent to arc tan v squared over rg. Okay, so this is the final answer. Okay, so let's go to the next example. A passenger on a carnival Ferris wheel moves in a vertical circle of radius r with constant speed v. The seat remains upright during the motion. Find the expression for the force the seat exerts on the passenger when at the top of the circle and when at the bottom. Okay, so pag nasa top, punta muna tayo sa top. Okay, if this is the seat, there will be a normal force, okay, and then the acceleration, okay, so that would be n, okay, at the top, the normal force, of course the weight, okay, there will be a weight, minus weight or mg, okay, equals, since the acceleration is towards the center and is going down, this would be negative m a rad, okay, or n minus mg is equals to negative mv squared over r. So n, because find the expressions for the force that the seat exerts, so the normal force, n is equals to mg minus mv squared over r. So let's simplify m, okay, g minus v squared over r. So this is for the equation of the normal force for uh, at the top portion of the Ferris wheel, okay, and at the bottom, okay, at the bottom, okay, n, okay, let's have the free body diagram, n and the weight and the acceleration is going to the center, so n minus mg equals positive m a rad, okay, why positive? Because the acceleration is going upward or towards the center, so n minus mg is equals to positive mv squared over r. So if we manipulate, the n is would be equivalent to mg plus mv squared over r, n equals to mg plus v squared over r. Okay, so this is the equation for the, okay, bottom part, the bottom part of the Ferris wheel. Okay. So let's proceed to the next topic, the fluid resistance and terminal speed. When we say fluid resistance, this is the drag, okay? Whenever a body is going towards a fluid like gas, air, wind, water, liquid, okay? This will be the equation for the terminal velocity. When we say terminal velocity, this is the maximum speed that the body can move, okay? Square root of mg over d, okay? So in example 23, for a human body falling through air in a speed spread eagle position, the numerical value of the constant d is about 0.25 kilogram per meter. Find the terminal speed for a 50 kilogram driver. So vt is equals to square root of mg over d. So vt is equals to m, which is 50 kilogram, times 9.8 over d, which is 0.25. Okay, so vt would be equivalent to 50 times 9.8 over 0.25, 44. Okay, since the fewest significant figure is this one, which is 2, so this is 44 meter per second. Okay, so how did we get the meter per second? 50 is kilogram, okay, and 9.8 is kilogram. Sorry, 9.8 is meter per second squared, okay, and 0.25 is kilogram per meter. So this would be cancelled. So the equation is meter squared over second squared, and then square root, that would be meter per second. So the final answer would be in meter per second. Okay, so that ends our topic for this video. Thank you very much for listening.